care about a lot, which is deployment. And I'm actually very, very excited for this talk about deploying Elixir clusters. So thank you so much, Raz, for being back. Round of applause, please.
I don't know why you can still see the top bar, but anyway. Cool. All right. So my name is Razvan. I'll be talking about deploying large distributed Elixir clusters. I presented this at Elixir Conf and I called it managing massive amount of Elixir clusters. I saw the presentation from Andrew Bennett at What's Up, where they talked about 40,000 clusters. So I changed my name. It's not massive anymore. It's called it large. Yeah, you can find me on GitHub and the app formerly known as Twitter right there. And I blog at Monkey Vault. What's the story? So I got nerd sniped while I was at Weedmaps many years ago. Somebody was telling me about how WhatsApp is running their servers and how there's no actual like state for the chat messages. Every phone connects to a chat like front end server, and when you message somebody, the whole runtime routes the messages until it gets to the mailbox, like the little mailbox that client is connected to, and that's how they see the message. And I heard that the two arrows, the two check marks in there, like indicate that one, like the chat server that you're connected to received it, and then the second one is that the other chat server received it. So anyway, long story short, I became fascinated with how they run their servers, and especially because if you look at common like knowledge for Erlang, the number of nodes that you can run is somewhere between 50 to 300, depending on where you read about it. And most of the problems, I became interested. Why is that? Why does it break? How does it break? So that's where I started my journey. I want to see maybe how many people played with distributed Erlang before or Elixir. Okay, so we have a good number. How many deploy more than 10 nodes? Great. Oh, nice. Okay, like that's great. That's who you ask questions to. 12. Cool. Yeah. So this is gonna be a bit dense. Like I have for like I'll give you a brief intro into distributed Erlang. I talked about the classic like Erlang distribution where you get global. It starts by default and it manages your cluster. And then the tuned version is no global. You start the distribution manually. No transitive connections. You use PG to manage the process groups, and you just scale it further, right? So 300 nodes is where the default one broke. The other one was 960, which is whooping value. At Elixir Conf, I presented Partisan as well, which is just a different topology. You don't connect in a full mesh. You connect in a directed graph, and you have kind of like a partial view of the system. I'm mainly a freelancer, and I work with a few companies, but one of them is Norton Labs. They actually sponsored this talk because I had to run thousands of instances on EC2, and I get into how I ran that. But that costs a lot of money, so they big thank you for sponsoring. They work in the intersection of blockchain and fintech, and they're hiring on all levels of Elixir. So very, very cool company. Let's get into it. So this is basically how you start two nodes. Very, very, very simple. This starts a chain of processes in the supervision tree, as we'll see. It starts very simple. It basically registers the node with this process that runs it's either started or if it's there, it uses it called Erlang port mapper daemon. And every as you'll see, it's quite magical. When you connect to a node, you don't need to specify a port. And if you work with many of those frameworks out there, Rails or you name it, try to run two of those in the same machine, and you get the conflict. Like, hey, something else is running on port 3000. None of this here, right? It's magic. Like you just specify the name and the host, and then it's connected. So this is thanks to EPMD, Erlang Port Mapper Daemon. It's a separate C library that kind of gets started when you started with the --s node or name, --s name or name, and it will assign a port to that current node, and whether you're connecting from a different machine or locally, it'll know how to address it basically in the system. That's how we list the nodes. This is my process running on the same machine, and as you can see, it is running on a default port, and I have two nodes. There's a base node that I select when I started with, and each node that runs with that machine will increment the port number. It starts from the base port 9100, and it goes 1, 2, 3, 4. That's basically what I did here. You see, I started IEX with min port and then a max port. So this is useful if you're filtering ports. Otherwise, if you don't specify those two boundaries, it will assign a random high like number port, and then good luck trying to figure out what to filter in your firewall. I've seen a lot of questions on forums where people can't connect, and that's one of the main reasons, especially if you're running AWS with security groups. So I said that starts the whole chain of processes. This is the big list. So there's global name server, which manages the whole mesh network. This registers all the processes. If it detects that a node is down, it will actually broadcast a message to tell all the nodes to disconnect from this node. That's they call it partition prevention. I think it's a relatively new feature. There's Erlang EPMD, which is the process that talks to the actual EPMD daemon out there. There's the net kernel that manages all the connections, the socket acceptor. It's a very similar pattern like Gen socket. It accepts connections to the server. There's a net driver that basically provides like a uniform interface from the operating system to the virtual machine. That's usually written in C. That's what actually does the syscalls to the operating system to maintain the connections. And there's the auth, but I think I'll focus on the net kernel here. So this is a little bit more in depth. As I connected the nodes, I wanted to know what is going on, which ports I'm using, and which processes are actually accepting messages back and forth. So this is a very useful command. You get the state of net kernel, and here for the two nodes that I connected, you can see there's a tick that runs it runs 4 times a minute by default. And we have the two, the PID is basically the acceptor, the connection acceptor for TCP, the process that keeps accepting connections and runs in the loop. And the port is the socket, basically. So what we can do, really cool, is set up an Erlang trace on the PID. So then we can see like the nodes talking to each other when we flash the message. Here you can see that we receive the tick and we reply to it. So that's very useful if you're debugging and you don't know why nodes are not connecting or why they're dropping the connection. And this is the next tick time setting. So this is a pretty important setting here. What happened was, as I'm deploying these nodes, I noticed that a lot of them would just disconnect. I would connect 300 nodes, and I would remote shell into one of them, run node list.length, pipe into length, and they would just drop intermittently. And it turns out that the net tick time was a bit high. It was 60 seconds, and it was causing some of the AWS routing and switching to drop idle connections. You know, it will just drop the connection. I was literally in that tracer, and I would just see connections drop without any other indication as to why. So I dropped it to 30 seconds. It fixed the problem. It's counterintuitive because a value of 30 means it's actually bombarding even more the other nodes, but it works. And I think WhatsApp is running this exact setting for 40,000 nodes. So it's quite impressive. you're basically not going to be able to saturate one operating system, ePOL or whatever queuing mechanism, just by heartbeats. Cool. So global is the other part of the whole distributed airline. Like I said, it maintains the network, it registers PIDs, and this was the first problem I ran into when I tried to connect nodes, just vanilla, just default. Turns out that the process responsible for maintaining the network is also the process that will kill your network if you grow too big. So this was, yeah, that's right there. This was the first error that I saw. Literally, I started with about 10 nodes and then 50 nodes. As I'm raising the number, I started seeing these messages. Basically, this is what I said earlier. Global detected a node that was down. It wasn't down. It was too busy and didn't respond quick enough to heartbeats, and it detected it as down, and it broadcasted to the whole network. And this is the setting that I basically had to turn off. I did the safest thing, like, let's have partitions, no problem, right? I should say that this is just a test. Like, I'm not running this in production, and I'm not using this for a project. It's just pure curiosity, and let's see how things break as we add more nodes. The last part is auth. So auth is deals with cookies. They're not secure at all. They're basically MD5, and compared across the network, it's kind of like part of the handshake that happens when nodes connect. They are more a grouping than security, because if you, let's say, if you want to make sure that one node doesn't connect to another group of nodes, you just use different cookies. I did try something interesting, because you can change the cookie at runtime. So I thought, why don't I connect a bunch of nodes together, right? And I have like a super node that, let's say, maybe we'll have this joint cluster. I will change the cookie as after I connect it to the other node, right? Because, hey, just the handshake, it compares it. But no, as soon as I change the cookie, I get a broadcast message that says, hey, disconnect, the cookie is changed. So no dice there. You either connect the node fully or you use something else like partisan. Now, I'll mention like the thing that I kind of have this hammer, right? But like I can connect all these nodes, and I'm trying to figure out like what can I use it for. And the truth is that you're not really like, there's a reason why there's not that many people that use distributed Erlang. Like, it's not in practice. Why would you really use it, right? I mean, if you want distributed state and you want to distribute it across hundreds of nodes, then you're probably doing it wrong, right? You should use a database. If maybe you're running a WebSockets and you're running a massive chat server like WhatsApp, then it makes sense. But even they use it, they don't share state as much as they use it for routing. From what I understand, that whole process that I explained where they route messages, that is using a modified runtime where they use some sort of like TCP like the routing, right? Where each message had like a TTL and so on. So that's interesting, right? Like, they're not sharing state, like, because I think once you start going down that path, that's definitely a flip gun, right? Where you start having partitions and inconsistencies. But Phoenix pops up was a cool example, right? Like that, I thought, like, what can I use on this 300 node cluster? Well, let me start a PubSub server on each node, and from one node I will broadcast the message, and I will record like how many messages actually receive it. I set up a simple RabbitMQ Broadway consumer that receives events. So this is what I noticed here, like up to, that should say, oh yeah, over 300. So up to 300 nodes, I get 100% deliverability for PubSub messages. That's what I showed to Chris McCord, and he was quite, because I went and asked him like, hey, you can connect 2 million connections to a Phoenix app. So if I have 1,000 of those, like, does it mean like I get like billions of people connected. It turns out no, there's still the Etsy table like limitation there because you have to keep track of all those connections. So it's not like infinite, but it's pretty cool. Up over 300, you run into head of line blocking and all these other problems that come with classic like distributed airline. Cool. So after I came back from Elixir Conf, I chatted with Andrew Bennett a little bit. He shared some of his VM parameters that they use there. There's like a secret gist file where they tweak all these parameters. They don't start the distribution automatically. They don't connect nodes automatically either. And this is basically what I pieced together. Like they don't really like share much of the setup, but there's no APMD anymore. It's just a simple like module that increments the ports and responds directly from the runtime. So there's no latency there. There's no global, and the distribution usually starts manually. These are some of the settings. So we get the base port. Again, like the first node connecting will get 8001, and then each node will increment this by 1. There's a setting connect all false. This means connections are not transitive. If node A is connected to node B and node C is connected to node D, node A and C will not connect together. Start distribution, that's pretty self-explanatory. It doesn't start the whole supervision tree, so you have to start it manually. It doesn't start Erlang port mapper daemon, and I wrote two very simple. I found I think Erlang Systems has a great write-up on how to write your own. There's if you go to Erlang's docs, there's a out disco section there where they tell you which functions to implement if you want EPMD less. That's what it's called. There's even a library called EPMD less. I think for newer version of OTP, you don't even need EPMD less library. You can do it with settings, but it's pretty simple. As you can see, it's pretty polite. The function name is actually called port please and address please. But basically the runtime will ask the daemon like, hey, given this name, what's the port? And this goes back to the first statement I made about connecting to different nodes without knowing the ports. That's how each node knows about the other node's port. And in this case, my implementation reads the node name and increments it based on the number appended to the name. So app will have 8001, app 1 will have 8002, and so on. That's very briefly like how the implementation looks like. The this port name will actually return the port incremented for each node. It's kind of very simple. That's not too far from how EPMD is implemented natively. And this is how you start the distribution. So when I'm talking about connecting 1,000 nodes, that's what I had to do on every node. After I deployed it, I started this in my application.ex manually. And going back to the same PubSub example, I went all the way up to 960 full mesh nodes, 100% deliverability. Once I get to about 1,001, literally the Erlang code beam loader just breaks. This is something I did even today, deploying. It's pending. I'll probably do another talk once I realize what breaks there. But if WhatsApp can do it with 40,000 nodes, it's definitely possible, but it probably takes years and years. And every single setting they use in that VM, there's a reason behind it, and probably somebody spending time researching it. But still, this is crazy. Like full mesh network. So if you watch my talk at Elixir Conf, I managed to get 900 nodes with Partisan, and that's the sparsely connected topology. you get about 50 nodes connected in an active view and about 100 nodes in passive view. And it's basically, it builds a tree, and then if you want to broadcast, it floods that tree. It basically goes, it keeps, each node has to keep track of all the messages it saw, and it floods all the other nodes it knows. So like it takes a while. Like for this, it took a few seconds for all the nodes to see the messages, but they eventually get there. Cool. Just really quickly, I have to deploy this, so I had a few options. There's a lib cluster, very famous library by Bitwalker. There's DNS cluster. It's a new one that I think FlyIO and Chris McCord like talked about it at Elixir Conf. It uses DNS to gossip and discover the nodes. It's quite cool. I think if you use something like Route 53 private DNS there, you can probably use it to do the discovery. In my case, I used this one, EC2 instances, polling the AWS tags. So I had Ansible and Terraform to spin the nodes. I set up a predetermined tag, and every time the node connects, every 15 seconds, I poll the API, get all the instances. I use a map set to figure out which ones that you're not connected to, and then just enumerate them and connect them together. Pretty simple. My next, so let me move on here. Yeah, this is why I needed sponsorship for this. This costs like $2 a minute or something like that, or like it's a crazy number. And also AWS will not just give you these instances. So I ran 17 of those, 20 actually today when I broke it with 1,000 nodes. So 20 of those, that's 1,200 virtual CPUs. And it took a couple of weeks to get this. They just, don't want to, I guess you could use it for nefarious reasons. You could probably, that's something I should have talked about, like how to build a botnet using the cluster. You can do some really crazy stuff with just if you have nodes connected, you can even change the code on all the nodes. So you have 1,000 nodes and you want to change this module and load another code on every single one of them. You can actually compile that code and send the payload, and every node will actually there you go, that was the CSIS like no but yeah. So yeah, I think if I want to get to 40,000 nodes, I'll need to use gossip and multicast, and that's really cool. What I did with this one, so I have 17 servers. I'm running 64 Elixir nodes per server. The local one uses a gossip, over the port range. So that's really cool. It connects right away. It starts in between the servers. I still have to do the tag API, but I definitely plan to do. It's called the transit gateway, so you can connect even multiple VPC servers together. Clusters together, and gossip the instances, which gets rid of polling, which is really cool. This is I probably spoke too early about this, but it just outlines kind of what I did to deploy. Terraform outputs a nice Ansible manifest. So and then from there I SCP released the release zip file, and I connect to one of the nodes with my super secret. But yeah, this is why. See, I told you I use those passes. You see? Yeah. So that's how I tested this stuff. Like I would connect to one of the nodes, and then I could see all of them. Yeah. So that's just the conclusion here. 1,000 nodes. I released some of this stuff. It's a bit of a mess now because I keep adding to it, but these are the two GitHub repos, which the distributed node is the sample. It's not even a Elixir, a Phoenix project, just a simple mix. That's it.
You should have a slide of like how many dollars it took to make this talk.
I thought about leaving those nodes running and doing a live demo, but
It's like,
yeah, it's dangerous. I went before I left to ElixirConf. I ran about 900 instances, and I have a screen multiplexer, so I detach and I let it run. I ran a Terraform destroy, and guess what? Like AWS has like rate limiting on
Right.
destroy, not on create. So 48 hours later, I get a notification. Hey, you have $2,000 like on your bill. I just almost fell off the chair. It's crazy. I mean, so
But
thankfully,
because it took that long to get down to zero.
no, they just killed my script. So they were just there. I ran. So these weren't those crazy ones. They were T3 small instances, which are still pretty pricey. Kudos to AWS. They're not sponsoring me, and they're actually like making it harder, but they actually reverted that. Like I
Oh,
contacted them, and it was literally the night of the reception where I saw like, okay, cool. This whole conference is not gonna cost me $5,000 just in my own funds.
That's awesome. Any questions?
Yeah, I'm curious. I get how you had to basically remove EPMD to get from 300 to 900. And I kind of expected your version to be like totally functionally different. And yet yours basically is everything EPMD does.
Right, yeah.
Which kind of implies that there's something wrong with the version of EPMD that's like, is there some, I guess what I'm getting at is it almost seems like whatever you did is what the main EPMD should be. Because like, what
Right.
did you lose out of, does EPMD list not implement anything that EPMD does? Or is it functionally equivalent?
I think it's functionally equivalent. To be honest, I didn't really check the whole source code to see what it does. I have a feeling it does a bit more, maybe.
A bit more, but like,
I mean, it forwards the connection, right? Because it actually orchestrates the socket connection. So when you say connect register node, for example, it will call inet, so like TCP and connect. It just forwards those. So that's what I did in my implementation.
yeah, well, which is super cool, but it definitely kind of feels like
It's-
there's probably an optimization there.
Right, and there's an EPMD less Rust myth as well.
Oh, really?
That somebody wrote.
Okay.
But I think it's just a learning process for me at least. Like you're right. I wondered about the same thing.
Yeah.
But WhatsApp is running the same. Like apparently they have. I literally asked them like, what do you do for EPMD? And they said we have a module that responds to port leads. That's all.
Interesting. Yeah, no, I just wondered whether like someday somebody should submit something back.
Right, yeah.
My other thought was like, you called it kind of like looking for, good use cases, I guess, for
Right.
a distributed cluster that big. I'm curious whether you considered messing around with amnesia. Like if you could actually get a distributed database running across 900 nodes, then that might be an interesting test case.
Right.
Do you know, like it must break long before 300 or 900?
I think so, right? Because
Say like 10 nodes.
10? Okay.
so
well, then
so
that's-
like even raft like I did that raft like a while back. I think what's gonna kill you is like a membership election, right?
Yeah.
So like with 1,000 nodes, you'll never convert. Like it'll probably take hours. And speaking of like with blockchain, right? They run hundreds of thousands of nodes, but they actually slowed everything down on purpose, right? It's like one block every like 15, I don't know, like 10 seconds or something. So they get away. Like that's how it works.
Okay.
That's.
So we're not getting 900 nodes.
But Chris McCord, if you
Probably don't want to because you have to replicate those. So you
Yeah.
probably
Yeah.
just want to do regions.
Yeah.
Right.
So you would have a cluster of like 1,000
Mhm.
Elixir nodes, and maybe only 10 of them are
Mm,
in these nodes, right?
Yeah,
or like consistent hashing and you shard like the data, right?
Yeah.
that's cool. I think, great talk.
Cool, thanks.
Tyler.
Yes, hello, can you hear me? Can you hear me?
Yes.
Perfect. Okay, that was great, Raz. This is exactly the type of stuff that I wish I had time and budget to mess around with because I've always kind of wanted to do some of it. First, I guess from my own experience, a couple of years ago, I was telling Matt that we did an experiment at work, and we kind of came to the same conclusion that you said early on. It's like distributing the state felt really bad and we didn't get very far with it, but using it as kind of a routing layer, we were able to actually like make it useful and worthwhile. So that was cool that we came to a similar conclusion. My question is that while you were talking, I just Googled for dist URL and there's not much that comes up. Is that what I didn't quite understand, or your diagram was very clear between your first setup and your second setup. But when you actually mentioned the term dist URL, is that just like a nickname that people use for an EPMD list setup? Or is that a library? Or I couldn't actually figure out what exactly that is.
I think it's a shortcut for distributed Erlang. I'm surprised like come up. Yeah, sorry.
Okay, so then what's the difference between, and that was your second scenario, or maybe I just misunderstood the title of the slide or something like that. Because I understand the difference between the first scenario and the second scenario was just basically EPMD versus no EPMD. But I thought something said, well, I probably just got myself confused.
No, I think I should have made that clear. It's basically the tune setup, right? Like this distributed Erlang tune doesn't start global. I think that is the main performance gain. Like you don't get global, which is not like global is basically an AP like system, right? So it prioritizes consistency over availability. So they slap this partition tolerance on top of it, which complicates things even more. But that's the thing. Yeah, no global and no EPMD. I mean, I think
Cool,
that's
thank you.
Okay, any other questions? No. Okay, well, thank you so much, Raz. That was fantastic. All right, that's the end of the.
Okay. I did not.
Well, that's okay. Can you still hear us?
The HDMI connection.
Just gonna say goodbye to them.
Tyler said thumbs up, so
Yeah,
probably can still hear
I
us.
think it's fine, but okay,
Okay.
we're back.
I was gonna say, yeah. Thank you all for coming and at home as well. Thank you for being with us. Thank you, Tyler, for always manning the room remotely. Matt, you're not.